Hi, welcome to another episode in the continuing saga of the art of physics. As you know, Professor Einstein and I have been having various conversations and even an occasional difficulty. And in fact, if you can have a look at what I've done with him, sort of, and in a way I feel like I have to apologize because Professor Einstein is truly a great man and did wonderful contributions to physics. But he did more than that. Not only could he play the fiddle, but he often did play the fiddle in some very interesting venues and for some very good purposes. Besides that, he was willing to talk about quite a number of things, and so I've used a number of his quotes. And although I kind of make fun of him in a way, I really love him because I think he's a terrific guy. He's done so much for physics and so much for humanity that I feel kind of a kinship with him, and perhaps he wouldn't mind if I made fun of him just a little bit occasionally. Perhaps he'll call again, although I hope that it won't be today, and I can ask him for sure. I guess I'd have to unblock his number though to do that. Oh, well, perhaps it won't happen right away. In the meantime, we're going to do something which is kind of unusual. There's a graphic which shows this. The title of this program is Try This at Home. Now, do you see what happens? There's some kind of a physics person with kids on a swing. Do you see that,
Yes,
Alexis?
I do see that.
And so I think that that's not exactly what we had in mind here today.
No, we'd probably get in trouble.
I think we would. But Try This at Home is an unusual thing because you see so many things that happen on TV where they say, this is done on a closed course by experts. Don't attempt this at home because you'll be suing the station. And we're not going to do that this time. We're going to do something that you can try at home. So to do that, I brought along an expert. There's an expert who has done physics lab things for quite a long time. This is Alexis Dodson.
Hello.
And I met Alexis Dodson in a physics lab a couple of years ago. And so we've been in and out of the physics lab together doing various things, helping people typically
absolutely.
to try to understand physics experiments. So I thought, who better to do a try this at home than somebody who knows how to do that kind of stuff.
Absolutely.
That's why Alexis is here. So they're just very simple experiments, but then physics is pretty simple anyway, as I'm sure you're beginning to figure out. Okay, here's what it is. We're going to start out with one of my favorite gadgets from physics, and that is a pendulum. Now, there are so many different things that can serve as a pendulum, and one of the easiest ones is this one. Namely, can you see that okay, Meredith? It's a yo-yo. So is a yo-yo a pendulum? Oh boy, is it ever. It's a very good pendulum, actually.
Everything's
So,
a pendulum if you're creative enough.
that's true. You can make pendulums out of almost anything, can't you? So we're going to use a yo-yo as a pendulum, and we're going to make a very simple measurement. That is, we're going to measure the period of the pendulum. How long does a pendulum take to swing from one end of the swing to the other end of the swing, and so forth. So we're going to do that, and Alexis has very kindly agreed to time this.
Yes.
And how are you going to time it, Alexis?
I am going to use something that hopefully everybody has at home. It's a cell phone, and most cell phones now come equipped with stopwatch devices, either in your alarm clock feature, or you can download an app for it. So this is very easy to access. You don't need a stopwatch. You can just use your phone.
There's an app for that.
There's an app for that. There's an app for all of it.
I think you're right. So in order to do this, we have to stand up a little bit here. So here's the pendulum. And I'm going to hold the pendulum all the way here so we have the full length of the pendulum. And what we're going to do is we're going to let it swing. And as it swings, it'll go from here to there. And so what I'm going to do is I'm going to count this, and I'm going to say 1, 2. Now, when I say those things, when I finally get to 5, Alexis is going to, well, actually, she's going to start at 1. Very good. And then she's going to stop at 5, and so she's going to time it. So let's see. This is going along pretty well. So when I say 1, you're going to start?
Okay.
1, 2, 3, 4, 5.
8.53 seconds.
Okay. Now, that wasn't really 5 swings, was it? It was actually 4, wasn't it? 1, 2, 3, 4,
Oh, yes.
Yeah, right. So then the period of that pendulum is
5-3.
divided by 4.
Absolutely.
So it's about a little over 2 seconds, right?
Sounds good.
Easy enough. So, but the thing you might be wondering about is, would that stay the same if this thing were heavier? That is, suppose that instead of having just a plain yo-yo, suppose that it had more weight to it. Would that change the period, or would it not change the period? It's hard to know that in advance. So, of course, physics has its way of finding out that stuff, namely experimentally. So what I'm going to do is I'm going to double the weight of this pendulum by hanging this measuring tape from it. And now we're going to try this again. Get the same swing and go. 1, 2, 3, 4, 5.
8.37.
That's not very different from before, is it?
No, not at all.
Well then, maybe it doesn't depend on the mass. Maybe the period of the pendulum is independent of the mass. Wouldn't that be an interesting thing if that happened?
Very much.
Wouldn't it? Well, how about this? Suppose instead, what would happen if we didn't make it swing quite as widely?
Okay.
Because then, maybe that would change the period.
Maybe start it at like a lower angle.
Start at a lower angle, and let's see what that does. So let's see. Before it started here, and I started it back here before. This time, instead, I'm just going to start it just like this.
Okay.
Okay, let's let it go just a little, and then we'll start. 1, 2, 3, 4, 5.
8.24.
Well, that's not very different than the others.
No, not at all.
So maybe the period of the pendulum doesn't depend on either the mass of the pendulum itself or doesn't depend on the amplitude of the swing. Either
At
one.
all.
Boy, that makes it real easy, doesn't it?
Yeah.
But that's not all. There's something else we could change, isn't there?
Yes, there is.
What?
We could change the length of the string.
I knew you would know that. Let's just change the length of the string. We'll do it about like in half and see what happens.
Okay.
This is about half the length of the string. So now I'll hold it here, try to get this other stuff out of the way. And now let's let it go again and see what happens. 1, 2, 3, 4, 5.
Wow. 5.82.
We got to figure it out, don't we?
Yeah.
What it depends on is the length of the string. So, do we have any graphics? Do you think we could make some technological thing based on this?
Probably.
What do you think it might be? Do we have a graphic that could show anything? Oh, what is that? Can you see it?
That looks like a grandfather clock.
Grandfather clock. So if you get it just right so that there's 1 second, then tick, tick, tick.
So if the period of the pendulum is 1 second, then you can use the pendulum to tell time.
Wouldn't that be nice?
That would be
so now you
great.
have a technological gadget. So where do you think this came from? Who had this idea to start with, do you think?
I would bet that it would be Galileo. He was quite interested in those kinds of
Wasn't
things.
he, though? In fact, there's a graphic which shows Galileo. And where do you think that is, that graphic?
I think that he was, I don't know which church, but he was at church, and instead of paying attention to what he should have been paying attention to, he was watching the chandelier swing.
Galileo.
Head in the clouds.
What a guy he was, right? There he is. Interesting fellow. I don't know if he'd be friends with us or not if he were around now, because he had a lot of ideas that were pretty
He was a little bit weird.
difficult.
Yeah.
But he got into trouble, didn't he?
Yes, big trouble. He thought that the Earth revolved around the sun instead of the sun revolving around the Earth, and boy, did that cause some problems.
Yeah, there was difficulty with that.
Yeah, they didn't like that.
But he got put under house arrest at the end of his life.
And they took his last name away.
Oh, Galileo Galilei.
Yep.
Scrub
Just
it off.
Galileo.
Just plain Galileo.
Yep.
So you get reduced to one name. So you'd be Alexis.
I'd be Alexis. I'd be okay with that.
Well, you're a duchess already anyway. So
Yes,
maybe
right.
you're Duchess Alexis. See, they can't do that.
No.
They would just have to call you plain Duchess then.
I wouldn't mind that much either.
You're so easy to get along with.
Thanks.
Gosh. Well, did you ever play with a yo-yo?
I have played with yo-yos,
you?
although, yeah, I'm not too skilled at them. I've heard that you are.
Well, it's partially because of experience.
Ah.
I've played with yo-yos since they made them out of wood. There used to be wood yo-yos made by Duncan, it's the same company that does it, but now they're plastic. And they do different things. They're tricks, yo-yo tricks.
Yo-yo tricks.
Yo-yo tricks. And in fact, if I can walk out here to the front of this, I think I need to do that because this needs a lot of room.
Yeah, you gotta stretch out.
Yeah. So let's see. Oh, this is going to be fun. Meredith,
Better watch
you're
out.
taking your life in your hands here because I'm going to do yo-yo tricks. And you know these darn things can get away sometimes. String can break, whatever. But let me just try a couple things and see what I can do. See, yo-yos just sit there for a while.
Is that one? Oh, is that one called walking the dog?
It's called walking the dog.
Okay.
If you make it go along the floor, then it's walking the dog.
Oh, how cool!
See, that's walking the dog. Okay.
Very neat.
That's one of the easier tricks. There's a few others. Let's see if I can do kind of an intermediate one. This is going to go all the way around. She backs up. I love
They
it.
should have brought their helmets.
Let's try it. There's no helmet. You have safety glasses on though, so it's okay.
That's good.
Let's try it. Around the world. Here it goes.
Woo! Look at that.
Not so bad, huh?
You're sharp.
Yeah, right. Also, lucky. Lucky helps a lot. Let's see if we can do one more. Our director, David Sommerfeld, and I were playing with this before you showed up, Alexis. And as it turns out, David had a misspent youth similar to mine. And so he and I could both play with the yo-yo fairly well. So let's see if I can do what we were trying to do before. Well, that wasn't it. But it's okay because
Ooh.
that is called rock the cradle.
That was super fancy.
That was trick number 10 in the lexicon of tricks, the hardest one. If you could do that, then you would win the yo-yo contest. And when I was a kid, when you won a yo-yo contest, you know what happened? They would engrave your name on the wooden yo-yo.
That is cool.
Is that terrific?
That's super cool.
I thought so too. I don't know if Einstein ever did that. I think he
Played
was
with yo-yos?
before
But
yo-yos,
he was
wasn't he?
He may have been. Also, he was a bit kinesthetically challenged, wasn't he? He tended to be a bit clumsy.
No, he
No?
could play the fiddle
Fiddle?
really well. So
Okay.
they had to count for something. Well, see, now you can try this at home. All you need is a yo-yo and a timer. And of course, if you do those other things, then that's up to you. That's harder. I can't instruct about that kind of stuff.
Yeah.
So, okay, that's one try it at home. We have another try it at home
Ooh,
that we'd like to
exciting.
use. And this try it at home is one which involves balls that we're going to drop. And these balls are going to drop and they're going to have a collision with this desk. Let me get this stuff out of the way here. And I'll have a collision with this desk and they will bounce up, hopefully not into your phone.
Yeah, we'll just put that down
They
there.
will bounce up and we'll see how high they bounce. Because depending on the collision, they might bounce almost to the level where you started, or if they're not very good, if the collision is not very good, then maybe they won't bounce so high. So what we're going to do is, let's start with this. We'll make this, oh, let's make it real easy. Let's make it 1 meter. That's now 100 centimeters or 1 meter. So if you hold that right there.
Yes, sir.
And I borrowed a bunch of balls here. I suppose they're called spheres, technically.
Well, if you want to be technical.
Perfect, but they're spheres anyway. And this one is one that's from a game called trackball. And that may appear in a later program too, so stay tuned for what happens to the trackball after this. But we're going to drop the trackball from 1 meter and see how high it bounces. Don't let it hit your finger.
Oh.
Here it comes. And can you estimate how high it goes? I'll look at it too. We'll both do it.
I think it'll probably bounce maybe a little bit less than little less than the height that it is now.
Really? I'll bet it's not
That was
going to go
like-
above 60
You
centimeters.
think?
See, that's what
All
makes
right.
horse races, doesn't it? You have differences of opinion. Ready? Here it goes.
Oh man, I suck at
That
that.
got to about, that got to about 50 centimeters.
I'm no good at this.
Well, it's okay.
We can't be good at everything.
No, you don't have to be. You're a duchess.
Exactly. I just
Jeez.
Comes naturally.
Makes it very easy.
All right.
Let's try, here's a marble. How high do you think the marble will bounce?
Now I don't know. I've lost my confidence. I think it's gonna go to the 60 centimeter mark.
60, I like it.
Are you gonna drop it from a meter though?
I'm gonna
Okay,
drop
yeah.
it from the meter. Whoa!
Did I get that?
That was, yes, I think it was about 65 or so.
Wow.
So that was better.
Getting better.
This one is known as a super ball.
Okay.
So what do you think a super ball is going to do?
I think it's gonna bounce back up to pretty much the same height it was at. Or maybe, no, okay. Let me go 80 centimeters.
Go 80? Yeah, I think 80 is good. If it goes to 80, then it's going to get 80% of the energy left. See, this has now some gravitational potential energy, and when I let it go, it turns it into kinetic. Hits the ground, the table, the desk, bounces back up again, and if the collision is perfectly elastic, it keeps all the energy it had, but it might lose some, and if it loses some, it's not perfectly elastic. We can see that maybe if it goes up to 90 centimeters, it's 90% elastic. Let's try it. Here it goes, 100 centimeters. Oh!
Oh my goodness.
Let's try that again. Did I do something funny?
I don't know. What is going on?
That's not much of a super ball. That didn't get above 40 centimeters.
More like ordinary.
Okay,
ball.
let's go into sports. Here's a baseball. So baseballs are pretty good, right? They probably have a lot of elasticity to them. How high do you think the baseball is going to go?
Oh man, I'm shaking again.
Does baseball scare you?
No, I get one ball and I guess the good height, and then the next one, I just
Can't have everything.
I know. Okay, so let's go 70 on that. Maybe if I say 70 enough times, it'll just be true one of them.
That got to about 43. So I guess a baseball maybe isn't that good. Okay, here's one. This is a racquetball. Ever play racquetball?
I have not, but I know somebody who plays a lot
Yeah, me
of
too.
racquetball.
Me too. Jeez. But I don't play much racquetball. Last time I played racquetball, it was a long time ago, and I hit the ball. I thought, you hit the ball really hard. It's good. Hit the ball really hard. And my partner, my opponent, was standing in front of me, and the ball went boop and hit him right in the ear.
Oh no.
And he fell down to the floor. I thought, oh no. And there was a little blood trickling out of his ear. I thought, uh-oh, I think I've done a terrible thing. He got up and said, not a problem. And proceeded to beat the daylights out of me.
Were you playing with Arnold Schwarzenegger?
No, it didn't need to be. This guy was even better. So anyway, do you think a racquetball is going to bounce high or what? What do you think?
I think probably. It needs to have a lot of bounce to do the things it does.
Yeah, I think so too.
I'm not saying numbers anymore.
Go to your 70 again.
Do 70? Okay,
Yeah.
I'll do it.
Okay.
70.
70 is right here. Let's see if it gets to there. Oh, it got above
Nice.
there. Probably 73.
Yeah.
That's terrific. See, you're getting better.
Yeah, see if I just keep saying 70 one of the times I'll be right.
Oh, here's another one. I borrowed this from Tiger Woods. This says, in tech, whatever that is. How far do you think this will go?
70.
Whatever I say, she says 7. Okay. Ready, set.
It's a good number.
70. She's got it.
It's a good number.
I'm not going to ask you what your IQ is.
70. No.
No.
I actually don't know.
It's better you shouldn't know.
Yeah,
Okay.
it's not important.
This one, oh, that's a kind of a super ball, I think.
Yeah, I don't trust those Super Balls anymore, though.
Um,
I'm going to go 50.
she changed her
Changing.
70.
It was the last Super Bowl.
Ready?
Didn't do me any favors.
70.
Super.
Super, huh?
Super Balls. 70.
She's got this
Back.
one. She
That one
nailed
looks
it. Oop.
Oh.
I think it got 73 again. Pretty nice.
That one looks like Jupiter. That's cool.
Okay.
All right.
Now, let's try this one. One more. Nice black ball. What do you think about this one?
70.
70. Ready for this? Here we go. Did you get that, Meredith? Let's try that again.
I feel tricked.
You are tricked. I think she got it. Did you get it? Let's try again. One more time. That didn't go anyplace. This is an example of a ball that had a perfectly inelastic collision with this desk. Inelastic means it lost all of its energy. So what did it do? It probably heated up a little bit, made a little sound. That's about it. So, but it didn't get 70, did it?
No, it didn't.
Oh, that's kind of a nasty break. But anyway, could you try this at home? Doesn't look that difficult. Just get a supply of spheres from wherever your local sphere store. Is that such a place?
I wish it was. I would go to the
You'd
sphere
go there?
store all the time.
Well, okay.
Sphere's a good shape.
Maybe it's right near the Apple store. I don't know.
There you go.
So, but anyway, you can do this. It's not a problem. So you can do that at home. So there, you can do your own physics. Don't you love it? Oh boy. That's about all I think I've got in the way of spheres to drop. I think that was it that I brought. But in any event, I guess I would like to talk to Alexis a little bit about some of the other things that Alexis does. So let's sit down for a minute, if we can do that. And I think one of the things I like to do for my guests is to Google them.
Oh, good.
So I Googled Alexis Dodson for the Google You. And so look what I came up with. The first thing I came up with for Google You for Alexis Dodson was?
A cookie.
It seems to be a cookie.
I'm a cookie.
You're a cookie? How did that happen?
I have no idea.
But it's a smiley cookie.
Yeah, it's a happy cookie. I guess you could describe me as a happy cookie. Maybe somewhere in the world somebody also thought I was a happy cookie.
That must have been it.
Tag
It's the
this
only thing I
photo.
can imagine.
No
So,
way.
but that wasn't enough for me. I'm never good with just one. So I Googled you further, and I got a picture of you on Channel 2.
Actually I did Channel 2 twice.
Isn't that the same as Channel 4? Two twos?
Yep, 2 twos.
Okay.
And I did, this is when I worked for a company called Lush, and they made like natural hair and skincare and stuff, and it was all handmade, and so it was, the way that you use it is different from like your normal shampoos and face washes and stuff. So we would frequently go and kind of do these demos, and I would wash the news lady's hand.
Oh, isn't that nice?
Yes, it was very nice. And she was always like, oh, it's so soft. They loved it when we came, though, because we brought goodies, too.
Oh,
so.
goodies. You know, goodies help a lot, don't they?
Yeah, they do. They invited us back quite a few times.
I'll bet they did. So that was you on TV. Now, of course, Channel 2, this is Channel 15. Now, so that's 7.5 times as good as Channel 2, I think.
Yeah, or 7.5 times better.
Better?
Are we allowed to say that?
I don't think we can say that.
Okay.
Can't say that. So, so you've done many different things. You're a cookie,
Yes.
you're a demonstrator, you're
Yes.
a student.
I am.
A helper at OCC.
Yes.
What else do you do?
Well, I do lots of things. I do enjoy traveling quite a bit. I lived in South America for a year, and that was, that was a good time.
Your Spanish must be terrific.
It was terrific. That was 5 years ago, so it's gotten a bit rusty. I can still read very well, and depending on the accent, I can still understand Spanish very well.
Wow.
Yeah. I'm not as good with, actually I'm not as good with the dialect from Mexico, because South America, they have a much more European influence to their Spanish. And the dialect in Mexico has like a faster clip that it's hard for me. It's a rhythm that it's difficult for me to hear.
Well, I want to ask you about what kind of things you do in school, because I know that you're involved in some interesting scholastic efforts.
Are we referring to my occupation as an SI or my personal studies?
Your personal studies.
My personal studies, well, I started at OCC in 2011, and I actually went back. I was working retail, and it was a very good company, and everything was fine, but there's a sort of a repetitiveness to retail that didn't really suit my mind. I wanted something that offered me more diverse thought, more diverse problems. And so I went back to school for anthropology, and I just happened to take a concepts in physics class for my lab class. And I don't know if you can say you're falling in love with the science, but boy did I. And it was amazing.
It got you, didn't it?
Oh, like I was hooked, and I was really enjoying my math class as well, and discovered that even though I had always thought I wasn't very good at math, if I actually had spent some time on it, I was actually quite good at it and really enjoyed doing it, and the two just sort of fit together.
Wow.
Yeah.
That's terrific.
Yeah, so here I am.
They tell us we only have 3 minutes left, so I want to ask a little bit about your hobbies, because I know that she is a cat lady. So
I am a super cat lady. So I do love pets. I have 3 cats. I would really like to sometime in the future run a cat rescue.
Wow.
Because I have a sort of affinity for broken cats, like the kind of animals that maybe nobody else would adopt. And I really get a deep satisfaction from taking those kinds of animals and, you know, whether it's a you know, behavioral issue. I have one that was just violent when I adopted her, but it was a really wonderful experience to watch her go from being a terrified, angry animal to somebody who now snuggles.
Oh, wow.
Yeah. I have another one who just is old and has health problems, really bad breath. He's a cuddler, and he gets in your face, and it's so bad. But I can't push him away because he's so happy.
I know what you mean.
Yeah.
Oddly enough, our friend Einstein actually has a quote that applies to Alexis,
Aww.
if you're ready for this.
I would love to hear it.
What he said was, our task must be to free ourselves by widening our circle of compassion to embrace all living creatures and the whole of nature and its beauty. I think that's one of the things Alexis does and does very well.
Oh, well,
So I want to thank you for being on the program.
Oh, thank
it's
you so
terrific.
much. It was so
enjoyable.
fun.
And all you viewers, I hope you enjoyed it. And until next time, I'm Art Wiggins.